Okay, so now let's take a look at this one. Set up the limit of the integration for evaluating the triple integral of a function capital F x, y, and z over the tetrahedron D, whose vertices are 0, 0, 0, 2, 2, 0, 0, 2, 0, and also 0, 2, 2. Okay, so this is the problem. And also it asks us to use the order of the integration dy, dz, dx. Okay, so this is a problem. What we would like to do is, first of all, let's draw the tetrahedron. Okay, so the point of 0, 0 is here. So this is x, this is y, no, this is z. And 2, 2, 0 is going to be a point lies on the xy plane. So if we skew, here is a 2, here is 2, and maybe here is also a 2 here. Okay. As you can see, so this is the point 2, 2, 0. Okay. And also the point 0, 2, 0, which actually is this point, okay, which lies on the y-axis only. So it's 0, 2, 0. Okay, that's the point. This is the point 0, 0, 0. And also, let's see, 0, 2, 2, which is going to be, let's see, a point some places here, right? This is going to be, let's see, 0, 2, 2. So that's the point actually lies in the YZ plane. Okay, so the tetrahedron, if we draw it, it's going to be something like this. Okay, so this is the tetrahedron. Okay, so actually it's there is one side, actually it's on the YZ plane. Okay, so the problem, it asks us to set up this triple integral in the order of dy, dz, and dx, right? So as you can see, if you want to draw a dy and dz, so basically, you know, you can think of you're gonna set up an arrow along this direction, and then of course this arrow, it enters with y. Excuse me, I think I made a mistake here. So in this way, it's gonna be working on dx first. So if it's a dy, so in that way, we actually gonna need to do along this direction. So in other words, if you, let's see, draw, let me use a different color to see if I can have a different one. Yeah, so if we are looking out for the dy first, so you're gonna draw an arrow into this direction. Okay, and then so it's kind of like a draw an arrow that is perpendicular to this face. Okay, so what do we want to do? We actually want to figure out, okay, what is the upper bound and the lower bound for y in terms of x, right? And after that, we're gonna need to look at, okay, what is the projection of the region of this tetrahedron on the z-x axis, right, on the z-axis. So if we just look at the, let's see, the, suppose this is the x, so this is the z here. So as you can think of here, this is going to be 2. This is also going to be 2 here, right? So if you think about it, the projection of this one on the z xz plane, so it turns out, as you can see, that this is going to be the region, right? So this is going to be the region here. So with this, so this is kind of like the pre-setup for how to think about this problem. And then we're starting to work on that. Okay. So the thing is, you see, the y, it is bounded above by 2, which is just this plane here. But it is bounded below by the surface, this side of the surface of this tetrahedron. So in other words, the first step, we need to find the limit of y, right? Of the y, of the integral. So that's the first step. And then more specifically, we need to find the equation of this plane first. Okay, so how do we find the equation? So we need to find the equation of this plane so that we can solve y in terms of x and z. Okay. So how do we solve this equation of the plane? Well, as you can see that we can construct the two vectors. So if we, let's do some denote. Suppose this is A, this is point B, this is point C, this is point D here. So right now we want to find the equation of plane containing T A N I N G. Okay, so containing points A, B, and D. Okay, so in other words, we would like to figure out the equation of the plane. So we can construct the vector AB. As you can see, it's 2, 2, 0, right? We can also construct another vector AD that is 0, 2, 2, right? So in this way, we are doing a cross product. So we can find that the normal vector is AB cross AD. Okay. So that is IJK, right? So it's a 2, 2, 0. Let's put the arrows here to be more standard. 0, 2, 2. Okay. And so we drive that. So it's a 4i, right? And then so here's a 0 minus 4, so it's a plus 4j, right? And here is a plus 4 k, right? So let me double check that. So hold on, let's see. Oh, I think that I made a mistake. So when you calculated this j, it's 2 times 2 minus 0, but there is a negative sign here, so it's going to be negative. Okay, so the vector is 4, negative 4, and a 4 here. Okay, and then now, as you can see, so it's fairly easy to figure out the equation of the plane containing this point A, B, and D. Why? Because it includes the points 0, 0, 0. So it's a 4 times x minus 0 minus 4 times y minus 0 and then plus 4 times z minus 0, and then that equals 0. So it turns out you can see it's a 4x minus 4y plus 4z equals 0. Then it's also x minus y plus z equals 0. So you can see that we can solve y in terms of x and z, which is y is equals x plus z. So you can see, so the limit for our y is bounded above by 2, bounded below by x plus z. So our limit for y is bounded below by x plus z and bounded by above by 2 here. Okay, so that's the first piece. So after we do that, and then we want to figure out, okay, what is our z, right? So what is the limit for the z here? So you can see that this is the corresponding xz plane here, and then this is a point 0, 2. So right now we only focus on this region in this plane, okay, not in space anymore. So this is a point 2, 0. So as you can see here, we can write the equation for this line, that is z equals, actually it's gonna be 2 minus x, right? 2 minus x, because when x equals 0, so z equals 2. When x equals 2, z equals 0. So it's very easy to figure it out. So you can see that z is bounded below 0, bounded above by 2 minus x. So the second step, limit of z, which is z is greater or equal than 0, less or equal than 2 minus x, right? And then the last one is super simple. So it's the limit of x. So you can see that x is the last part, and so it's going to be bounded by some constant. So x is from 0 to 2. So x is. So now with every pieces here, we can write our integral into the triple integrals from 0 to 2, from 0 to 2 minus x, from x plus z to 2, which is right here, and then the function capital f of x, y, and z. So you're gonna have it's a dy, dz, dx. Okay, so that finished this problem. Okay, it's a little bit long, but definitely it's manageable. So thank you for this.